Okay, here are the solutions to the equations of log functions, formative assessment. And notice you do have 2 attempts on these formative assessments now. I think that's only reasonable. I'll get my pen happening here. More gadgetry. There we go. Okay, so keep in mind the question numbers are randomized, so you might not have exactly the same first question that I do. So we have to figure out the equation of this function. Now, of course, first things first, where'd my pen go? Recognize that this point is, of course, that magical distance of 1 unit, which would mean this is my pretend x-axis, which helps me identify the translation up 2 units. And of course, I think the easiest thing is our vertical asymptote is at 3, so our function has to go 3 units to the right. And so since I found my magical distance here of 1 unit, I just have to recognize that this is my base, this distance, because notice that's 1 unit above. So if I go over 4 units from this vertical asymptote, I'm going up 1, so that means whatever I can put 4 units measured from that vertical asymptote, 4 is outputting 1. So of course, what does that all mean? That we have basically just a translated log, so the equation here should be y equals, no stretches, it's a log, base 4, since this is the distance, exactly 1 unit above my pretend x-axis. And of course, we want to make sure our function is translated 3 units to the right. And pretend x-axis is up at +2. So we'll go down below here and try to find, oh, I shut off my ink. I guess I better leave that open. We'll go down here and try to find that equation, which is log base 4 of x minus 3 plus 2. There's a dizzying amount of possibilities here, but there's the first question down. So I will trash that and move on to number 2. Okay, so different color, I guess. So notice starts off the same way. We need the equation of this function, and I'm recognizing that right here I got my magical distance of 1 unit, which is right on the x-axis, so my function wasn't translated up or down at all. So here we're going to go with y equals, possibly a stretch. Maybe I'll just get the obvious stuff down first. Don't know my base yet, but I do know this function has to go 1 unit to the right, and it's not going up or down at all because notice that magical spacing of 1 unit from our vertical asymptote is sitting on the x-axis. So this is my base, this distance right here. You know, since we've established that we're going to use this ordered pair and not that fractional one, my base here is 3. This is the shortest way of doing it. And then this is your stretch. So this is going to be a vertical stretch of 2 by a factor of 2. And if you're seeing that, awesome. If you're not, then of course don't panic. We'll I guess just input this ordered pair, which is 4 and 2, into our kind of incomplete equation here, where we're not going to consider a stretch for the time being. So if I put in 4, this log should output 2. So this is going to give me, I guess, write it out, 2 equals log base b of 3. So if I go to exponential form, this is b squared equals 3, which looks like we'd have a plus or minus root 3, but of course our bases can't be negative now. Of course, that's a messed up base, so how do we get away from this? Well, if I have any more space here, I guess I can erase this. How big is this eraser? It's not too bad. So I'm just going to sub in my messed up base of root 3, and then of course do a change of base and figure out what's happening here to match the options, of course, that are down below. So same color, we'll say, we need a pencil, y equals log, and a square root 3 of x minus 1. I mean, I guess you could look down for that option, but it's not there. So let's do a change of base. We'll go obviously to base 3, since this is a base 3 raised to a power of a half. And then I put 3, or the square root of 3, down below of x minus 1. And hopefully you can take a few minutes to decode this. This is just log base 3 of 3 to the power of a half. So 3 to what power is 3 to the power of a half? And of course the answer is a half. So we're dividing by a half here. So that would mean our final answer is going to have a 2. in front. So there's my final answer in terms of the box here, and you can ignore all that rambling and scribbling down below. So now we'll just go down and look for 2 log base 3 of x minus 1, and I'll shut this off. 2 log base 3 of x minus 1. 2 down, 2 more to go. Okay, this one's slightly easier, but I guess they're all, initial reaction to all these is probably quite similar, like, oh no. But turn this on, and notice, I guess I need to trash that from the last question. Use black this time, and I'm going to look for my magical spacing of 1 unit from my vertical asymptote, which is there. And of course, I'm not using that point with fractions. I'm not really confident at all what that x value is, but of course, we're also going to use the ordered pair 1 and minus 3 here. And I think you can see your vertical asymptote is to the left 3 units. So again, I'm just going to hope there are no stretches and I don't get a messed up base. And if we do, we'll do a change of base and clean things up and look for an option that's down below. So y equals log. Don't know the base, but I know this thing has to go 3 units to the left. And since my magical spacing of 1 was right here, that whole function has been translated down 2 units. And now, of course, we'll input our x and y value of 1 and minus 3 and see if we can figure out what this base is. Now, if you can visualize this from the graph and determine this from the graph, go for it. I forgot to write in my x value, talking and writing at the same time. So x was 1, we outputted minus 3. Okay, so we'll add 2 to both sides. This gives me negative 1 equals log base b of 4. And then exponential form will help us decode what we need here for a base. So b to this power of negative 1 must be 4. Reciprocal of both sides would mean our base is a quarter. So I would be looking for, I guess in a nice bright pink here, I'll scribble it here. We need a function that's y equals log base a quarter with the 2 translations, x plus 3, and then subtract 2. So it's probably sitting not too far from me here. Oh, a distractor that's kind of evil with that extra negative out in front, which is not what we want. There's our correct answer here. So log base a quarter of x plus 3, all minus 2. And I'll clear all this off. And we got, I think, 1 more left. Yes, number 4. Okay, so this is actually the easy one. So I got kind of unlucky here with the randomization. Gave me the easiest question last. But anyway, turn this pencil back on. And maybe we'll do the easy ones first. Let's sub in minus 3 here. So what happens if we sub in negative 3 into this? Well, we got to contend with 2 times log base 3. Negative 3 goes in here. Negative 3 plus 6 is positive 3. So this, of course, is going to give me 2 times 1 minus 1, which is positive 1. So I need to, I'll just write a 1 in here for now. Of course, I'll type that in later. Okay, and similarly, I'll just erase this and this stuff. I can now sub in positive 3. So if I put positive 3 in here, I get 3 plus 6 in the input, which is 9. So now I have 2 times 3 to what power is 9. That, of course, is a square. We need to apply to our 3 there to get 9. So this y value is going to be 4 minus 1, or 3. And I'll just write that in and type it in later. And now for the, I guess, the hardest part. Get my eraser going here. Get rid of that. And now for, the hardest part. And we'll just sub in negative 1 for y. And a ugly yellow here. But anyway, we'll put negative 1 in for y and try to figure out what x value we need here in order to accomplish this. So x plus 6 minus 1. Okay, so kind of a log equation, but again, don't panic. Just figure out what x is. So let's clean this up as much as possible, and going to exponential form will help us towards the end. So let's add 1 to both sides, and that means 0 equals 2 log base 3 of x plus 6. And I can divide both sides by 2, and here's an equation that we have to figure out of x plus 6. So I basically, hopefully you can clue in that this has to be 1, because 3 to the power of 0 would have to be 1. And if you're not seeing that, go to exponential form. Base 3 to this exponent has to equal x plus 6. And yes, that is the number 1. And if we subtract 6 from both sides, we'll have x equals minus 5, which I'll just pencil in here for now. And we'll type those in a few more minutes, and I think we're in business now. The rest is pretty easy. The equation of the vertical asymptote is, of course, whatever makes the input of your log equal to 0, or also clue in this log has went 6 units to the left. So I'll put in a minus 6 there. And if I can scroll down, I think, I guess I can't scroll down because that's all going to move. So why don't I take a second and I'll type this stuff in. Please don't put any spaces or extra characters in here, or you will be marked wrong. And I do happen to scroll through, and I usually look for stuff like that. If somebody accidentally puts a space or any extra characters, I'll give you marks for it. So there, I got those values typed in before I wipe it clean, and then we'll go down here and see what the last question is, and it's the domain question. So of course, if you recognize there's no reflections involved here at all, I can shut this thing down. No reflections involved at all, and of course the inequality is given to us anyway, and it's actually correct now. Notice there's no line underneath that inequality that there accidentally was in your first formative assessment. X can't be equal to this minus 6 value, and of course that's the location of your vertical asymptote. It can't be equal to it since that's right at the vertical asymptote, but it definitely can be greater than minus 6, and if you're still not sure, pick a value bigger than minus 6, like minus 5, and if we think of putting it into this logarithm, I can put a minus 5 in there and I have a positive number, so we're all good. I don't have 0 and I don't have negative values. So there it is. Of course, now at this point you should be able to see your answers here, and I'm just previewing this as a teacher, so I have a different experience than you. So hopefully you're seeing which questions you got wrong, and you should be making note of that. And of course, if you're lost or confused, hopefully this fairly short video helps you out.